Hello, everyone. We're just going to wait a couple of minutes, see if any people kind of join, or any more people join, I should say. Just while we're waiting, I guess say that there's a Q&A function. So if you find that at the top of your screen, I think, then that's how we'll do any kind of questions and stuff as we go through. All right, everyone, let's make a start. My name is Simon Mayer. I'm a lecturer in sustainability at the University of York, and it is my pleasure to be addressing you all today with colleagues Alberto, Mariana, Luis, and Luz, who's in the background kind of running the event for us. We're going to be talking about some work we've been doing as part of the MSPACE project. So it's Marine Spatial Planning Addressing Climate Effects. And we'll talk through a bit about in a moment. But mostly what we want to talk to you about today is this particular framework we've been using called input-output analysis. Give you an understanding of how we've adapted that to address specific kind of policy relevant marine and climate issues, and show you some of how we've used it and how we hope that you might use it as well. So Marine Spatial Planning Accounting for Climate Effects is a project funded under the SMMR scheme as part of NERC and ESRC. And the overall project is aiming to understand how different climate change scenarios play out in terms of marine resources around the UK. And that's particularly work which has been led by Anna Quiroz in PML, and then understanding through kind of Gina Reinhardt and Ocean Marcone's work about how different communities feel about about activities that happen in the marine space, how they might be impacted by climate, and how they value these different activities. What we're going to specifically talk to you about today is the economic analysis which sits alongside that, where what we're attempting to do is take the marine climate modeling, which has been done down at PML, and link it to economic impacts, partly through some of that kind of scenario work which comes out of the valuation stuff. So with that, I'm going to hand over to Alberto, who's going to talk you through the methods that we've used around the economic analysis.
All right. Do you hear me? I can control? Yes. So, okay. Thank you, Simon. So let me explain briefly that the initial problem that we face when we tried to model it, to construct the model for the MSPACE project. So initially we had the original input-output tables for the UK, namely for the Scotland, Northern Ireland, and Wales, and for the whole UK. But however, we have 4 case studies, different 4 case studies. Two out of them actually were at regional level. So we have already available data for the the national tables, but we need to disaggregate and to construct the regional tables. Another issue that we faced at the beginning that was that these input-output tables that are constructed, provided by the statistics office are really robust and well established, but they aggregate the industrial sectors in a very high level. Mostly, most of the marine-related activities are concentrated in one block. So this provides an loss of efficiency actually in analysis. So, sorry, yes. So, sorry. Yes. So sorry. Yeah. So this is briefly, this is the overview that the procedure that we follow from the beginning. So this is what our plan was. So we started from the input-output tables at the beginning. As you can see, they provide a huge variety of sectors, but just a very small size of the sectors represent the marine activities. So we needed to do a procedure that is the disaggregation. What we call it is adding detail to these sectors, okay, collecting the necessary data in order to construct what the models that were going to be applied in the case study analysis. So before going further, it's important to just briefly explain why we use the input-output tables. But basically, it's because they are data-driven and very simple models, but at the same time they are very powerful. Because then they don't require to collect really complex data or to construct the model, even though it takes time to construct each of the model. So these models, what provide us is to give a set of indicators that give information on the impacts of the linkages throughout the supply chain. These impacts can be measured in terms of employment, gross value added, income, wages, even emissions. This provides to link identify these kind of frameworks to be very powerful to identify what is the connection between the production systems and ecological, social, and environmental impacts. So the impacts on these indicators are measured what they are called direct and indirect impacts. That basically the direct impacts are those that are given in the sector that the shock is produced, all right, and then the indirect impacts are the ripple effects. So this methodology helps us to give information, provide us information not only on the sector itself but also on the whole economy, all right. So this is sorry. Yes. So this is a very simplified version of what is an input-output model. The first thing that came to mind is that they have like a matrix shape, all right? So basically, this is we can divide it in three big parts. This is imagine the center part is the yellow one that represent the interaction between the sectors. So basically that represent which sector buys from, which sector sells to. So the sector one buys from sector two, sector two, sector three, and so on. But at the same time, this sector sells to its production to the sector one, sector two, sector three, and the remaining, the surplus of the production is also sell to what is called the final demand. This information is collected by the final demand that at the same time we can disaggregate it. We can include information by household government spending, also fixed capital formation, investment, basically, and the rest of the production that is not sold among these sectors, these economic agents are sold to exports. At the bottom, we see that's the vector of the gross value added, jobs, and greenhouse emissions that are linked to each marine activity. This helps us to complete the big pictures and analyze which are the connection within the economic system with the social and environmental impacts, economic impacts. So this is what is basically the big picture of the system. So as you remember, the first issue that we need to face, to address in this case, was the disaggregation of the model. Why? Because the information is provided at really high level. So the information of most of the marine activities are hidden in very broad sectors. So just taking as an example, most of the marine sectors are grouped So this is the case of the fishing and aquaculture. So imagine we are measuring the impacts of one policy in the fishing sector. In this case, if we don't disaggregate these sectors, the impacts are for the whole sector, for the single block. So we need to separate these vectors, all right? So the first part, just collecting the necessary information and apply some mathematical approaches. We try to separate. Basically, what we do is we divide the columns and rows into several ones. So as you can see, what we do is we increase the linkages between sectors. All right, that provides us more detailed information about what is happening actually between the fishing sector, the fishing fleet sector 1 with the fishing fleet sector 2, and so on. All right, so this is how we get better detailed information after the disaggregation. This is a very simplified picture, but we do with a very big models that can take even 125 sectors. So this is the process. As you can see, this is the robust part of the information is that this is evidence-based method approach. So just for disaggregating it of the sectors, we use the different sources, data sources that we have displayed on the right side on the table. As you can see in the first column, this is the original table, how it's displayed in the input-output tables originally. All right. So after doing a disaggregation process, we obtain the middle column, the sectors that are in the middle column. As you can see, we increase the number of sectors from the original page part. All right. So after doing this process, for the first step in the project, we obtain we disaggregated the original input-output tables, all right, and we increase the number logically. We increase the number of sectors, as you can see in on this slide. We increase the number of total sectors, but compared to the original one, and also what we were interested to is we increase the marine focus sector, all right. Then this is very important improvement in the sector in the project. Actually, this is a robust step. But then some sectors were still large scale sector to analyze a base scale case studies. All right. So we need to do a second step. The second step, what is called, is the regionalized process. All right. Basically, sorry, the regionalized process is taking. Sorry. Oh, sorry, it's not working good. Sorry. The regional process, sorry, was here. So the regional process. So we do that regional process. So basically, just broadly speaking, the regional process is trying to translate what is the national data, try to connect it with a local case study. In that case, without going into detail, we use like what is a statistical tool that is allocation coefficients, that basically using employment data, we found out which sectors are concentrated in the regions, which are the important ones. Yeah, according to this coefficient that we estimated, we could include in the model which sectors were present or not in this region. All right. So this is for the intersectional matrix. All right, the yellow one. So then we use different approaches just to construct the final vector, the blue one, and the bottom vector, the yellow, the gross value detector. So we use really specific local data. So with this disaggregation, we obtain a really detailed information that captures the characteristics and peculiarities of each region. Finally, after constructing what is all the vectors and putting them all together, what we needed is to rebalance the tables. Actually, we need to rebalance the table is just try to equalize. No, we must make equal the outputs and the inputs of the sectors. Okay, because in that way we can make the data internally consistent and reliable for the analysis. So after doing this procedure, that we were able to construct. So we were able to construct the final two regional models for the east of England and Orkney Islands. Basically, even though I enjoyed the most to construct those last models, actually these models were the most challenging ones because they need really detailed information. But at the end, we were able to construct the models were the foundation for the rest of the project to carry out what is the analysis. The next section will show you with the application of these models. Thank you.
Cool, thanks, Alberto. I think I've
Thank
got
you, Simon.
control back, so let's see. Yeah, so what Alberto's given you there is kind of, I guess, an overview of the technical detail of how this data set is produced. So this data set is available online now. There's a link at the end of the presentation, and I'm sure we can share if anybody wants it as well. So essentially what we have then is we have 6 input-output tables that are available to you to do any kind of analysis or to speak to us about. What I want to give you a sense of now is how we've used the tables and how you might use these kind of models as well. So immediately with the data that we have available, you can do some really interesting and I think quite powerful analysis without having to kind of manipulate the data too much at all. So what you can see on the slide here is a plot of what we call multipliers. So Alberto talked about using these models to estimate direct impacts and indirect impacts. So direct impacts are the impact that happens in a focus sector when there's a change in kind of demand or output. So if we're talking about a fishing fleet, then direct impact in terms of employment would be people that are employed actually on the boats doing the fishing, right? Indirect impacts are estimated through the model in terms of everything else that's in the supply chain. So it's people that are employed building boats, people that are employed in financial activities insuring boats, anybody you can map through that production process. The multipliers that are here are showing you both the direct and indirect impacts, and the y-axis is greenhouse gas emissions, so tons of greenhouse gases emitted per million pounds of output, and employment, so people employed per million pounds of output. And our argument in the paper, which is cited here, is that using these stats, which you can pull directly out of the data sets that we've made available, you can very quickly start to understand the relationship between different economic impacts. So here we're presenting greenhouse gases and employment, but we can do the same thing for value-added employment, value-added and greenhouse gas emissions. And our argument is that this can act as a very quick and reasonably robust kind of first pass at any kind of policy analysis for marine spatial planning. So because this data is available, because we have multiple metrics, and actually the work that Lewis and Mariana did have added additional metrics to some of these, you can very quickly start to see what might be focal sectors that you want to kind of investigate further in a kind of policy setting. You can of course do more sophisticated analysis with this data set, and where we're going with the MSPACE project, I think Anna is on the call, so she can correct me, but very soon I think we're going to have some kind of quite detailed reports available looking at some of these scenarios, is to connect these up to other modelling techniques or other policy proposals and think about what the impacts might be. So in MSPACE, for each of our case studies, the map here is illustrating Northern Ireland. We have 4 scenarios. So we have business as usual, which is essentially what are the impacts of climate change if we don't attempt to adapt our marine spatial planning to it. Conservation and food production, which are management scenarios where we focus on optimizing either for conservation or for food production, and then a compromise scenario, which is more of the, I guess, kind of pragmatic balancing of those two potentially competing priorities. And so what we can do is, or what's been done in the MSPACE project, is kind of careful development of this kind of collaborative set of scenarios with different stakeholders for each of the case study areas, and then we link them through to the input-output models to look at the economic impacts. So what you get out of that kind of analysis is something that looks like this. So each of these plots that you can see is a different economic impact that we can readily do in the model. So we have labour compensation, which is essentially wages, gross value added, greenhouse gas emissions, and then the number of people engaged. The blue bars are direct impacts and the green bars are indirect impacts. And what you're seeing here is for the East of England case study. And the in each chart, the first bar is the baseline, so our estimate of the situation as it is now, and then the second bar is business as usual. So what are the impacts of climate change if we don't try and adapt? And what you can see is that we expect significant losses in a kind of business as usual scenario. So about a reduction of about a third across all of our impact variables. This slide is showing you also for the East of England, but here comparing business as usual against conservation. And I wanted to show you this as a kind of a potentially kind of counterintuitive lesson that can come out of this kind of analysis, because we might the difference between the conservation scenario and the business as usual scenario is that in conservation we are identifying areas in the marine space that are going to be relatively kind of protected from climate, so refugia. For different species, but we are closing those off for food production, which we would expect to have significant negative economic impacts. But actually what we find is that because the business as usual impacts, the impacts of climate change are so large, at least in this case, we wouldn't expect really any additional economic loss due to additional closures from conservation. Cool, and at that point, I'm going to hand control over to Mariana, who's going to talk through some work that we've done on tourism. Mariana, you're muted, sorry.
Always happen, thank you. Hey everyone, thank you so much. Just to talk a bit briefly about this part of the paper. In this case, we wanted to take tourism from a different perspective, in a more holistic view. Basically using socio-ecological system frameworks, as everybody knows that main systems are interconnected in every sense. So we found that tourism, in terms of the impact that has and the interconnection that has with different sectors, is one of the most reliable to be using this type of technique. We are just trying to expand some of the work from McGuinness and Ostrom from 2014. And we are able to understand that humans, economic, and obviously the nature are interconnected itself. So how we do it? Basically, we did a mixed analysis or mixed methods, starting with qualitative research, trying to understand how are different stories or signals happening globally to be able to create some scenarios, some plausible scenarios, basically using foresight. And then using some of the specific data that we have with quantitative models, with some money flow. Specifically, looking at the East of England, we were looking at the cost of travel spending, and we were able to map those, link it with the socio-ecological system framework. To give you an idea, the socio-ecological system framework has some building blocks, 5 specific sections, and then we are able to identify specific indicators that are able to connect with the spending. And that's how basically we're trying to understand how the East of England, in the case of tourism, has impact in jobs, not only in the economic aspect, but also in the nature and the community dynamics. This will explain you a little bit how we were able to integrate these two sections with the qualitative narratives and the quantitative.
Okay, I think that now, yes. So, okay, I'm trying to move to the next slide, but I'm not sure if I have the, yes, okay, now. So according to the approach that Mariana was telling you before, what we were doing is trying to define 4 different narratives for different scenarios. And through these narratives, we were including in the tourism spending, and then we were observing the potential consequences that has in the economy. So we have 4 scenarios, plus if we consider also the business as usual, that very well mentioned before Simon, that is what happens to the economy if we allow, if we allow the society to work as it is. And then we have created 4 different scenarios that we have implemented to the different, we have implemented to the tourism expenditure, and then we have observed the consequences. So, let's start by the sustainability, that is just the balance or economic growth that balance also the environment and the society consequences. Then we have created another scenario that is the technological driven, that is what happens if the growth of the economy is based on technological innovation. Then we have designed the low impact tourism that is focused on this, or is this a scenario where we try to reduce the consequences of the tourism by, for example, doing, low carbon activities, or maybe reducing the transport. The consequences of the transport, or taking more sustainable ways of transporting. And then we have the transformative systems, that is more a sense of regenerative, like taking all the ecological infrastructures and taking advantage of these technological infrastructures by growing and trying to reduce the potential ecological impact. So in few words, in the graph that you have on your right, we are comparing the difference between the 4 different scenarios with the business as usual. According to the narratives, what we observe is that, for example, we have the low impact on tourism, that is one of the scenarios that provides a low growth or economic growth, but also reduce greenhouse gas emissions. Then we have the transformative systems and sustainability, that you can find it on the it has a positive economic growth, but with a negative environmental impact. And then on the corner, top right, you can find the technological driven scenario that is based on technological innovation, and is one of the scenarios that, of course, it has a higher gross value added, but also it increases the greenhouse gas emissions. Specifically, one of the things that we have done is analyzing these the consequences of these scenarios. I'm trying to move to the next slide. Yes, thank you. So we have computed the potential consequences of each scenario by including also social impacts and the previous slide. Yes, we have computed the potential impacts of the scenarios by the impact in the social dimension, but also in governance that we have. For example, the regulatory quality score, that it provides the efficiency and coherence of all the institutional rules. And then the voice and accountability, that is when the stakeholders are able to participate in these rules. So briefly, we explain among the different scenarios. What we observe is that, for example, we have 2 scenarios that are similar, that is the sustainability and transformative systems, that they have the same impact. Okay, but also we found it's a different impact in the governance that has a positive impact in transformative systems. Then we have low impact tourism that has different implications in the social dimension. For example, it can generate a higher employment gender ratio. And then we have the technological driven, that also it has, despite the potential consequences in the environment, also it has a balance in reducing, for example, the employment gender ratio. So next slide, please. Yes. Finally, what we observe, or the findings that we have in our in this research that we have done, is that the technological driven scenarios, for example, is one of the scenarios that boosts economic metrics, but also harms the environment and the risk governance. Then we have the sustainability and transformative scenarios that reduce the tourism environmental impact, and also it addresses the social inequalities despite economic decline. But also we have observed that there is a difference between the government's structures, between both of them, where the transformative has better ratios with respect to regulatory quality and voice and accountability. And then also one of the things that this model is helping us is being able to compare 4 different scenarios through this integrated mechanism that Mariana has explained before, where we combine the narratives of the socio-ecological scenarios framework with some quantitative metrics analysis that could be the input-output that help us to analyze not only with respect to the economic and environmental dimensions, but also to understand what happens to the social and governance dimensions. Thank you.
just to complement a little bit, here when we are looking at this research in particular, obviously there are so many research in terms of input-output tables in tourism and foresight scenarios as well. However, we have been able to find one that is able to combine both. In this case, when we are looking, or most of the cases when we are looking into the social aspect, is only related to job positions. We wanted in this opportunity just to integrate also the qualifications in terms of education and also the progression in career. Most of the time we ended up seeing that tourism is able to create jobs, which is an amazing opportunity. However, what quality of jobs are we looking at? So these indicators added were able to support us to give like more strength to this support to this paper. In addition, also the governance. Governance is one of the indicators that we added later on. As you have noticed before in the numbers, when we look at sustainability and the transformative systems, the numbers weren't that different at all. But at the moment that we add governance, that's basically what controls the different narratives that we ended up seeing in each scenario. So as Luis was mentioning, at the end, we are not aiming to spec this is the right scenario or you should look for this other. In this case, we're just trying to show you a landscape of potential opportunities that could happen or influencing policy. And based on that, we are able to adjust different techniques or different strategies to make sure that obviously there's some economic support, but also not affecting the nature and making sure that the cultures and the dynamics in the society is still working properly. Simon would like to continue.
Yeah, thank you. So we are more or less wrapping up now. Hopefully what you've got out of this is a kind of a sense of what data we have available, which is summarized here on the screen, and you can access it at this link, which is down at the bottom, but also a sense of what you can do with it. So we have analyses or analytical opportunities which range from the very simple of taking the descriptive statistics embedded in the data sets that are already available to do some kind of quick sort of prioritization of different kinds of relationships, or they can be linked in a variety of ways to different, more complex modeling approaches and scenario development approaches. Yeah. So if you'd like to access the data set itself, it's the links up at the top. The technical report, which sets out in more detail what Alberto has talked through in terms of how each table was constructed, is available at the second link. And then the first paper that's been written from this is available down at the last link, and that's the one which looks at the UK level, plotting out different multipliers. Please do ask any questions you might have, or feel free to contact any of us about any of this analysis. We're really keen to kind of get this out there and get it in use. So thank you very much. If anybody has any questions, so if the Q&A box is available, I guess we'll hang around for maybe. Oh, I can see Jamie, you've got your hand up. I don't know if I'm able to give you. Oh yeah, I can. Here we go. You should now have your mic available if you want to unmute yourself.
Yep. Can you guys hear me all right?
Yeah, go for it.
Brilliant, thanks. So Jamie Johnson, I'm a marine planner at the Marine Management Organisation. Thank you very much for the time today, going over your very, very interesting research. A lot of it over my head, I have to admit, but lots of food for thought. I guess my question, just where I've been coming at things sort of through my role and or previous roles, looking at sort of employment metrics and things like that, was I guess how adaptable are the methods that you have presented here to other areas in I'm thinking in the marine space for England, because obviously that would be useful if we can have a sort of standardized approach if we were to take these forward that we could use across all marine plan areas in England, and also to have something that would be used to firstly establish a baseline for marine sectors, but then also to monitor change over time, so we can monitor the effectiveness of our policies, as well as testing potential future scenarios and future plan development. Sorry, lots of that question, but
no, that it's super useful. Thank you. I mean, yeah. So Anna's put a link in the chat. So there is next Monday the launch of kind of the next phase of this project, which is the MSPACE project. And Anna, maybe I don't know if you want to kind of say a little bit about that.
I can, if you like. So, hi everyone. Well done to everyone on the really nice presentations. Yeah, just to say, so the some of the models presented here are integrated in the MSPACE tool, which has been co-created between this project team, the wider MSPACE project team, and colleagues in the marine policy communities and marine industries across the UK. And so the tool is an assisted spatial prioritization tool, which is really geared towards the creation and analysis of planning scenarios, but also so for those interested in investing in nature, in growing marine sectors, in marine plans. And so the economic model, particularly that Alberto described, and the tables that Alberto and Simon created for the MSPACE project are part of that tool, and could be used in that way that Jamie was referring to, with all the raw data or the underlying data already published as well in the links there in the chat. I don't know if that helps, Simon. Cheers.
Yeah, definitely. But I mean, in terms of a question more generally, all the procedures, well, I mean, Alberto did most of the actual work, so I'm speaking for him, but I think all the procedures that we employed are, there's no reason that they couldn't be employed for other regions across England. So the way it works is we start from, there's an official kind of data set published for the UK as a whole, and then we added kind of marine sector detail to that, and that's available in one of its links. And then because it was a specific case study for MSPACE, we went down to the East of England level, but there's no reason you couldn't apply the same procedures to go to develop tables for the other kind of English marine plan areas as well. Does that help, Jamie? Does that make sense?
Yeah, no, that does make sense. Thank you. I think we've got a similar approach that we already use, but I'm interested to know what the difference is between our existing methods and the ones that you guys have developed.
Anna, it's very good of you to raise your hand, but I mean, you can.
Yeah, just for anyone on the call, I was wondering, Simon, should I just show an example of how we're taking this forward, and then how the metrics are incorporated in that tool?
Yeah, go for it.
Yeah, just really quickly. So just for those that might be interested in the going forward and answering a little bit Jamie's question. So as I mentioned, that we are integrating these economic models into the MSPACE tool that's coming up, and that's really geared towards special management decisions. And so this is one, a type of output you can get out of that. So here we have the whole English planning area, for example, and in blue we have the MPA network, and in red we have the current wind licenses. And what we've tried to do is try to identify areas that could be used for compensatory measures for the wind sector. So where could new areas be allocated for the English Marine Protected Area network, avoiding areas where there are new wind leases. So for example, and that's the yellow, so that comes out here. And so what we can then see is that depending on how much of that yellow area we select, you can then apply the economic model to look at compare alternative scenarios. So for example, if we ask the tool to look for increasing those compensatory measures by expanding the marine protected area by 4% or 20% or 30%, this is just like hypothetically. And then what we can look at is, using particularly the models that Alberto presented, we can look at changes in greenhouse gas emissions in the region. We can look at changes in the gross value added relative to the business as usual. We can look at changes in labor compensation relative to the business as usual. And we can look at different scenarios and how those metrics change. How does the number of jobs change between different scenarios? And then there's a bit more around it as well, around the value stakeholders hold in the region. So you could deploy this in a standardized manner across England, for example, if you were looking at this level of questions, which are more sort of at the nation level, and then make decisions based on, a really standardized set of indicators, which is underpinned by the economic model, and to help make those decisions. So I think that's not quite what the MMO uses, and that's where sort of this tool and these models might help.
Cool, thank you, Anna. I'm afraid my screen is frozen for everybody. Has anybody else got any questions?
I don't see any other questions in the Q&A chat.
Cool. Well, in that case, maybe we'll say thank you very much for coming, and please do get in touch with any of the team if you've got any questions or ideas for how we might take this forward. Thank you.
Thank
Okay,
you.
thank you,
Bye.
everyone. Thank you.
Thank you, everyone.
Questions. Bye bye.